The birth of a programming titan, C's origins. C, a powerful and versatile programming language, has a rich history dating back to the early 1970s. It was created by Dennis Ritchie at Bell Labs, building upon the foundation laid by its predecessor, the B programming language. Developed for the Unix operating system, C quickly gained popularity for its efficiency and portability. Its influence can be seen in numerous programming languages that followed, solidifying its place as a cornerstone of modern computing. Before C, programmers often relied on assembly languages, which were closely tied to specific computer architectures. This made it challenging to write code that could run on different systems. C addressed this limitation by providing a higher level of abstraction while maintaining close ties to hardware. This unique balance of power and portability contributed to C's widespread adoption and enduring legacy. C's impact extends far beyond its initial use in operating system development. Its influence can be seen in diverse domains, from embedded systems to game development. Many popular programming languages, including C++, Java, and Python, draw inspiration from C's syntax and concepts. Understanding C provides valuable insights into the principles underlying these languages, making it an excellent starting point for aspiring programmers. Unlocking a world of possibility. In today's rapidly evolving technological landscape, learning C programming offers numerous advantages. C is considered a middle-level language, bridging the gap between high-level languages like Python and low-level languages like assembly. This unique positioning gives C programmers a deeper understanding of how software interacts with hardware, making it ideal for system-level programming tasks such as operating system development and embedded systems programming. C's versatility extends beyond system-level programming. Its efficiency and performance make it well-suited for developing high-performance applications such as games, graphics engines, and scientific simulations. Moreover, C's concise syntax and direct control over hardware resources make it a popular choice for resource-constrained environments such as embedded systems in consumer electronics and industrial automation. Learning C also provides a strong foundation for understanding other programming languages. Many modern languages like C++, Objective-C, and C# are built upon the principles of C. By mastering C, you gain transferable skills that can be applied to a wide range of programming paradigms, including object-oriented programming, functional programming, and procedural programming. This versatility makes C an invaluable asset for any programmer's toolkit. Setting up your C workshop, compilers, and extensions. Before diving into the world of C programming, you'll need to set up a proper development environment. This typically involves installing a C compiler, which is a program that translates your human-readable C code into machine-executable instructions. Two popular choices for C compilers are GCC, the GNU Compiler Collection, and Clang, both of which are freely available for various operating systems. Once you've installed a compiler, you'll need to understand the concept of file extensions. C source code files typically have the extension C. When you compile your C code, the compiler generates an executable file, which can be run on your computer. The exact extension for executable files varies depending on your operating system. For example, exe for Windows, and no extension for Unix-like systems. To create and edit your C code, you can use any plain text editor. However, using an integrated development environment, or IDE, can greatly enhance your productivity. IDEs provide features like syntax highlighting, code completion, and debugging tools, making it easier to write, navigate, and debug your code. Some popular IDEs for C development include Code, Media Code, Blocks IDE Interface, DevC++ IDE in use, Visual Studio Code with C/C++ extension open on screen, Blocks, DevC++, and Visual Studio Code with the C/C++ extension. The anatomy of a C program: structure and organization. A C program follows a specific structure, which dictates how your code is organized and executed. Understanding this structure is crucial for writing well-organized and functional programs. At the heart of every C program lies the function. This function serves as the entry point for your program, and the code within it is executed when you run your program. Before the function, you'll often find preprocessor directives, which start with the hash symbol. These directives instruct the compiler to perform specific actions before compiling your code. One common directive is, which is used to include header files. Header files contain declarations of functions, variables, and other elements that your program might use. The code within the function and any other functions you define is enclosed within curly braces. This block of code defines the actions that your program will perform. C uses semicolons to separate individual statements within your code. Proper indentation and spacing are also important for readability, although they don't affect the program's execution. Section 5. Building blocks of C keywords and data types. Keywords are reserved words that have special meaning in the C language. These words cannot be used as identifiers, such as variable names or function names. Some common keywords include yatati and. Understanding the purpose of these keywords is essential for writing valid C code. Data types define the kind of values that a variable can hold and the operations that can be performed on them. C provides several fundamental data types, including used to store integer values, for example, 10, -50, used to store single characters like I, B, or $, used to store single precision floating point numbers such as 3.14 or -2.7. Used to store double precision floating point numbers like 2.71828. Choice of data type depends on the specific needs of your program. For instance, if you need to store whole numbers, you would use. For storing textual data, you would use or arrays of to represent strings. Section 6. Input, output, and making your program speak. Input and output operations are crucial for interacting with users and displaying results. C provides standard functions for performing I/O operations, allowing your program to receive input from the user and display output on the console. One of the most commonly used output functions is, which allows you to format and print text and values to the console. To use, you provide a format string as the first argument, followed by any variables or values you want to include in the output. The format string uses format specifiers, for example, for integers, for floating point numbers, for characters, to indicate where and how the values should be inserted into the output. For reading input from the user, C provides the function. Similar to uses format specifiers to indicate the type of data to be read from the input. It also takes addresses of variables as arguments, allowing it to store the input values in the specified variables. Section 7. Controlling the flow, operators, and decision-making. Operators are symbols that perform specific operations on operands, which can be variables or values. C provides a rich set of operators for arithmetic, comparison, logical, bitwise, and assignment operations. Arithmetic operators include plus, minus, multiplication, division, and modulus for performing basic mathematical calculations. Comparison operators like equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to are used to compare values. Control flow statements alter the sequential execution of statements in your program. These statements allow your program to make decisions, repeat blocks of code, and jump to different parts of the code based on certain conditions. Statements execute a block of code only if a specified condition is true. Statements provide an alternative block of code to be executed if the condition is false. Loops repeat a block of code as long as a specified condition remains true. Loops provide a concise way to iterate over a range of values and repeat a block of code for each value. These control flow statements provide the building blocks for creating more complex logic and behavior in your programs. Section 8. Functions, the workhorses of your code. Functions are self-contained blocks of code that perform specific tasks. They promote code reusability, modularity, and readability. By breaking down your program into smaller, manageable functions, you can make your code easier to understand, debug, and maintain. Functions can take arguments, which are input values, and return values, which are output values to the caller. To define a function, you specify its return type, name, arguments if any, and the code to be executed within the function body. The return type indicates the type of value that the function will return. If a function doesn't return a value, its return type is. Functions are called by their name. followed by parentheses containing any arguments to be passed to the function. When a function is called, the program's execution jumps to the function's code. Once the function finishes executing, control returns to the point in the code where the function was called. Section 9. Data structures organizing information effectively. Data structures provide ways to organize and store collections of data in a structured manner. C offers several built-in data structures such as arrays, structures, and unions, each with its own characteristics and use cases. Arrays are used to store a fixed-size sequential collection of elements of the same data type. Structures, on the other hand, allow you to group together variables of different data types under a single name. This is useful for representing real-world entities that have multiple attributes. Unions provide a way to store different data types in the same memory location, but only one member of the union can hold a value at any given time. Pointers are variables that store memory addresses. They provide a way to indirectly access and manipulate data stored in memory. Pointers are particularly useful for working with arrays, structures, and dynamic memory allocation. Strings in C are represented as arrays of characters terminated by a null character. C provides a library of functions for working with strings, such as copying, concatenating, comparing, and searching. Understanding these data structures is crucial for efficiently managing and manipulating data in your C programs. Section 10. Commenting your code, a guide for humans and yourself. Comments are essential for making your code understandable to both yourself and others who might read or work with your code in the future. They are ignored by the compiler, so they don't affect the program's execution. C supports two types of comments: single-line comments and multi-line comments. Single-line comments start with 2 forward slashes and continue to the end of the line. They are typically used for brief explanations or annotations within your code. Multi-line comments start with and end with. They can span multiple lines and are often used for more detailed explanations, such as describing the purpose of a function or a complex algorithm. Effective commenting involves striking a balance between providing enough information to make your code understandable without overwhelming the reader with unnecessary details. Comments should be concise, clear, and focused on explaining the why behind your code rather than simply restating what the code is doing. Section 11. Compilation. Bringing your C code to life. Once you've written your C code, you need to compile it to transform it into an executable program. This process involves several steps, including pre-processing, compilation, assembly, and linking. During pre-processing, the compiler handles preprocessor directives, such as including header files and expanding macros. The compilation stage translates your C code into assembly language, a low-level language that's closer to machine code. The assembler then converts the assembly code into object code, which is a binary representation of your program. Finally, the linker combines the object code with other necessary libraries to create the final executable file. To compile your C code using GCC, you can typically use a command similar to. This command tells GCC to compile the file and create an executable file named. If your program consists of multiple source files, you would compile them together using a command like. Once compiled, you can run your program by typing in the terminal or command prompt. C programming offers a powerful and versatile toolkit for building a wide range of software applications. From system-level programming to application development, C's efficiency, portability, and low-level control have made it an enduring language in the ever-evolving world of technology. As you embark on your C programming journey, remember that practice is key to mastering any new skill. Explore different concepts, experiment with code examples, and don't be afraid to make mistakes. The more you code, the more comfortable and proficient you'll become. Keep in mind that this is just the beginning of your C programming adventure. There's much more to learn and explore.